So welcome everyone to the Simio Solutions Series session here, 2023. Today's session is understanding row reference hierarchy and changing row references. My name is Dan Vasilini. I am the VP of Global Sales here at Simio. Doing most of the talking and presenting today is going to be Liz Miller. You can see both of our email addresses and titles on the screen if you do want to reach out and talk to us at some point in the future. Couple of housekeeping items before we get started. Please keep in mind today's session is being recorded for replay purposes. If you'd like to watch this session or you'd like to reference it onto a colleague or have someone else watch it, it will be on the Simio webpage here. Usually we have it up and running probably in about anywhere from 12 to 24 hours based upon the recording and the download and everything, but assume by early next week it'll definitely be up there. Also be alert, everyone will be entered on mute today. If you'd like to ask a question, there should be a GoToWebinar dashboard somewhere on your screen. Sometimes it usually pops up on the right side. If you've moved it, it might be somewhere else on your screen, but it is a GoToWebinar dashboard. In that dashboard, there is a question box. Anytime you have a question during today's session, please feel free to type a question into that area. Today's session is scheduled to last about 60 minutes. Generally, we leave time at the end for question and answer, but I know that Liz told me that today's session will probably be about 40 to 45 minutes of presentation. So be aware we may run out of time for questions. So if you do have questions during today's session and you type them in and we don't get to them, we will make during the session, we'll make a point of getting back to you or trying to help out here in the very near future. And then I will publish or put our names and email addresses up one more time at the end, just in case you want to reach out to us directly. All right, for future sessions. So we have two more currently on the calendar. The way we're doing these this year, for anyone that has not yet attended, we're doing the second Friday of every month. So one per month, second Friday. Next one is scheduled for June 9th. Then we have one on July 14th. And then we also have one on the calendar for August 11th. That topic is still to be determined. A month from now, we'll be doing the implementation of lifecycle. 2 months from now, project modeling, scoping strategies, and then, like I said, to be determined on the 11th of August. If you do miss them, as I said at the beginning, we always record these sessions and they're on the Simio webpage. So you always can go back and watch one or catch up on something you might have missed. Last time I'll do this for 2023. In case you were unaware or were unable to attend, we did do Simio Sync in the early March. Simio Sync is our online user conference or our annual user conference. We've been doing it online for the last couple of years. All of the presentations for Simio Sync are on live or not live. They're recorded and up on the Simio webpage. If you just go to that address you see there, you can register for the event, go in and watch any of the sessions you'd like. And you can see we had a host of different people, from big names to small, but McDonald's, Alcoa, Bristol-Myers Squibb. You can see just to name a few that were presenters during the presentations. Some good content that was in there, so I'd highly recommend if you were unable to attend, just getting registered, and you can go back and watch these sessions at any point in time. And I said this will be the last time I talk about this because we will probably be moving from the platform of registering to getting these sessions up to the Simio webpage here soon. But for now, at least you still have to register to get into the platform to watch. So with that said, Liz, I will turn things over to you and you should be ready to go.
Great.
Let me get share over to you because I know you're probably gonna ask, how do I get access? You should be presenter now. Maybe. You got it? There you go. Perfect.
Awesome. You see my screen? Great. All right. As Dan said, today's focus is understanding row reference hierarchy and changing row references. So if you weren't able to catch our Simio Solution series from last month, Chiara did a great job presenting about data tables and when you might use relational data structures to further enhance your models. So we're going to be continuing on a little bit further with that, but mainly focused about row references. So we're actually going to jump right into an example model to demonstrate a lot of this. So we're going to be working out of this small example. And here's just a simple model. We're going to have two different value-added processing locations, which is represented by server 1 and server 2. And at these different locations, we're going to have multiple tasks occurring, and that's going to be modeled with task sequences. So here, our task sequences are going to live in a data table, and that data table is going to feed the information into the servers. So here I already have this set up where server 1 and server 2 are both referencing a table processing tasks. This table was just made from our table schemas. So if you're unfamiliar with our table schemas, you have the option to add a table and add a data table from a schema. And this just gives you pre-made data table schemas for all of the elements and objects inside Simio along with their repeat groups. And the processing tasks data table schema is under the server. So you can quickly add this in and it'll make a data table that has columns that correspond to each of the properties in that either object or element or repeat group. So here we're just matching all of the properties that are in the task sequence repeat group. And I've just filled this in with some information. So I just gave it different sequence numbers and different task names. So today we're going to be using some different methods for verifying that our model is doing what we expect it to. And one of those is by using log resource usage, because this will allow us to look at the Gantt. So the Gantt will help us see what tasks are being done at each location. If I run, I'll just run for a little bit, and we go to results and go to entity Gantt. We can see that we have different information tracked for each of the entities. And we're just gonna narrow in on the first entity here, and you'll see that as I expand it, I now have the option to look at the tasks, and we're gonna zoom in. Oops. And we can see that this first entity, it went to server 1 and then server 2, and it completed a bunch of tasks. And we can see that these are the task names that match our task names in our data table. But as we can see, it looks like it did the same tasks at server 1 and server 2. So this is because as we feed a data table into a repeat group, we can see that there's this top level reference, and that means that each row in the data table is going to be an item in the repeat group. So right now, this server sees all of these rows in the data table, and it does each of these items as it's going through and enacting the task sequence. Okay. So if I wanted server 1 and server 2 to do different tasks, I could give them different data tables, but then I would need a data table for each server. Whereas I'd rather just have one data table and be able to have each server know that different tasks in this data table belong to that server. So as we can see with my naming, there's S1 tasks and then there's S2 tasks. So ideally, I would want this section of tasks to belong to server 1 and this section of tasks to belong to server 2. And one way of accomplishing that is by using our relational data tables. So I'm going to add in another data table, and this is going to be a server data table. And I'm going to add in a object column, which will be my servers. Reference server 1 and server 2, and make this a key. Back in my processing tasks table, I'll add in a foreign key. And as you add in a column, it always throws it on the furthest right-hand side. You have the option to move columns left or right, and there's also a drop-down where you could move it leftmost. So we're going to move it all the way to the left just so I can easily see it on the side. And we're going to reference that table we just made. So I can say that these first few tasks belong to server 1, and these tasks belong to server 2. Great. So now as we run, we'll just let that first entity get through the system. If I go to results, I'm seeing the same tasks done still at server 1 and server 2. So where did I go wrong? Well, we're going to jump back to my PowerPoint for a second and talk about some of the tools that you can use to help understand row references. So a couple helpful tools, and depending on the circumstance, you might check out different tools, but one of them is trace. So with trace, you have advanced trace options where you can turn on trace table resolution, and that lets you see more detailed information about the different row references each object has when it's evaluated at the different point in the process logic. We also added a newer feature in 247, Sprint 247, where you can now watch an object or an element and you could see its table row references. And then we also could use notify steps. So if we were doing something with process logic, we could use a notify step to help, look at the tokens associated object or context object, see what objects potentially might have row references. And we can also put in a table reference in the notify step so that we could use that in combination with trace. So our notify step pauses at a point in time in the model, and at that point in the process logic, we could use trace to see, what are the different row references. So we're going to use the watch window right now. So jumping back to my model. And if I just run and pause, I want to ensure that my servers have row references, as that's the relation we just set up in our data table. So if I right click on the server and I watch, we open the watch window, and we see that there's this section for table references. And if I expand this, I see that there's nothing here. So we must have gone wrong somewhere. So what happened? Well, let's go back to our data table. So we set our foreign key. Our foreign key now gives the key kind of this information that there's this subsection that it knows in this table. So this row does know that these rows in the processing tasks belongs to this key, but we didn't tell the servers that they should know this is their row. And a quick way to do that if you're using object or element references is to just click on that column and use auto set table row reference. So here we just want to change that to true. And then each server should know and remember that this is their row. And so once the server remembers that's their row, it knows its key and it knows that this is the subsection it should be doing when it runs and looks to reference this table. So now if we run and go to results, I see that there's a different set of tasks done at server 1 and a different set of tasks done at server 2. Well, let's take this a step further. Let's say my system actually had different part types going through it, and I wanted the different part types to have different tasks done at each server. So here in the naming of my tasks, you can see I have part type tasks for A, B, and C. I could set up a similar relationship with the server table where I make an entity table and give the entity a key. That would work out well if I decided to have multiple entity instances. So if I had an entity instance for part A, an entity instance for part B, and part C. You might consider using different multiple entity instances if you wanted to collect statistics on those different instances. That would be a useful way, or one reason you might have different part type instances. But in this case, we're just going to use the default entity instance and instead make a table and use a string to represent the different part types. So each part type will just know a string that says if it's A, B, or C. And this is just to demonstrate a couple other ways we're going to look at row references. All right, so I have part A, B, and C. And I'm going to also want to give a mix of how often we expect to see each part type. So let's say 50A, 30B, and 20C. So now I have a string that could represent my different part types, but how do I ensure that my default entity knows which row it belongs to or which part type it should be? Let's jump back to my PowerPoint for a second. So setting table row references, there are a couple ways to set table row references. One of them we already saw was by using the auto set table row references property on a object or element column, and that will set the row to that specified object noted in that row of the table. You could also use some properties on the source. So if your source is creating entities from an arrival table, the source will know the time of the arrival, and the entity will also remember that row of its arrival time. There's also a property group on the source for table row referencing, so you could assign the entities row references as they are created or before they're created. For process logic, you could use the set row step, which is one of the main ways you would assign a row reference. You could also use an add row step, and that's specifically for output tables. So as you're adding rows to output tables, as you add a row, you will remember that row and that part in the process logic, so you can continue on and make assignments to that row. Something else that also gives row references that we don't often think about is if you're using a search step and you're searching a data table on the found branch of the data table, or sorry, on the found branch of the search step, the token that leaves the found branch has that row reference to the data table. So maybe your object that triggered that process doesn't have that row reference, but the token does. So you could always use the token's information to assign that later. Okay, so we're going to use some of the sources information to assign these row references. So here in the source, we have this property group for table references. So before creating an entity, we want to reference an existing row for the entity table. And the row number that we want to reference is where we're going to use this mix. So we're going to say entity table dot mix dot random row. So that's just going to say use the weights of my mix column to pick a random row, and then that row will be selected and that entity will remember that row. Right. This would be a good time to practice some other verification techniques, but since we're a little bit short on time, we're going to skip that today. But this could be a time where you use animation to maybe assign a different color for a different part type, or add a status label that says that part type. But we're just going to, again, use watch and look at our table row references and see that the entity now has different row reference available. So here we see it has an entity table. This entity is looking at row 2, so we know it's part B. All right. And I realized we actually skipped over looking at our server row references, which is something I wanted to come back to. So we're still watching server 1, so I'm going to open that up quickly. And after we turned on the auto set table row reference, we see that now it has its reference to server table 1, row 1, because it's server 1. And we'll also see that it should have, oops. Yeah, okay. So continuing on, so now we want to say in our processing task table, if I am a specific part type, we want to narrow in on that part type and narrow in on those rows for the table sequence processing task table. So I'm going to give our entity table part type column, I'm also going to set that as a key, and I'm going to add another foreign key into this table, move it all the way left, and say it's going to reference our entity table. And here I'm just going to fill in the different part information. Take a second to do that. All right. So one of our practices we like to do is we like to form a hypothesis of what we expect to happen, and then run our model and kind of verify that what we expected to happen is what we see. So let's do that. what we currently expect is that we expect the entity to go to a server. So when we're at server 1, we expect these rows to be filtered down for server 1. And then we expect the entity to be able to filter it down even further. So if I'm entity A, I expect to only see these rows. Okay, well, let's try it out. Let's run and pause and look at the results. And the results look pretty similar to what we saw before, where at server 1, we're doing all of the different parts for server 1 tasks, and at server 2, we're doing all the different part tasks at server 2. So nothing has changed. So where did we go wrong with our assumptions? Well, this is another good time to try and use one of our other tools for understanding table references. So I'm going to turn on trace, and we're going to use trace table resolution to look a little bit deeper into what's happening when we go to the server and try to evaluate the table for the task sequence. So I'm going to turn on trace type, trace table resolution. I'm going to add a breakpoint. Oops, breakpoint. And I'm going to fast forward and step, step. Okay, so quite a few things happened. And we have to go back up a little bit. You'll see that when you turn on trace table resolution, if there's a lot of things that are using table references, it will really expand trace. You'll get a lot of more information. So you have to be careful about when you turn this on because it could slow things down depending on what's happening in your model. Okay, so going back to the top, when we're about to go evaluate our task sequence information, so we see that we are resolving our rows for the processing task table. We see that these are the row references we have available. So we see that our token has row references, our associated object, which is our default entity that's at the server, has row references. And we'll see that our property object, server 1, also has row references. So the token matches what the associated object default entity row reference has. So we see that both of these see entity table 2, and that give it a set number of potential rows in the task sequence table. So if we're looking at our data table, if I see row 2 in the entity table, I expect to see these rows in the processing task table, right? So I would see 5 rows. If I am the server, I see these rows. So I see 7 rows happening here. Well, let's jump back to the PowerPoint again. As a data table reference is being resolved, you can only come at the data table reference from one perspective. So while we had hoped that the server and the entity could both narrow down the potential related rows in the processing task table, you can only have one object, one element, one token resolving the row reference or resolving the table reference with its row references. And so we have this hierarchy that we follow that says, starting from the top, if there is a row reference available for the owner of the property or the property parent, that we would use its row references. If this doesn't have any row references available, then we'd use the tokens. If the token doesn't have any available, then we would use the parent token. So in a case where you're in process logic and a token had created a child token, that child token would then look back to its parent token to see if it had any references. If we can't use the parent token references, we would use the token's parent process element. So the process itself can remember row references. And if that doesn't have any references, we would then use the associated object, which in this case was our default entity that triggered the process. And if that didn't have anything, then we'd use the context object or the entity instance. So the entity instance means our actualizations or realizations are the entities that are moving through our system. The entity instance that is used to create those can also hold and remember row references. So if you were putting those in data tables, it could remember that as well. If you need more information on this, I highly recommend checking out the help page. There's a help page titled Tokens and Processes, Discussions and Examples, and that goes over this hierarchy as well. So it's available there if you need to look at that again. But in this case, so the property parent, what does that mean? Well, the property parent is the object that owns the property that has the table row reference in it. So in this case, the server is the property parent. It owns the task sequence. So it's going to use the server's row references to resolve the related potential rows that we're looking at for the table. So that's why we're still seeing the server's information being used and we're not considering the entity information. Okay, so what can we do about that? Well, we really want the entity to be the thing driving the information and kind of narrowing in as it goes to different locations what it should be doing. So we actually don't want the server to remember this information. So we're actually going to take away its row references. And just to verify that we then see the entities references being used, we're going to run again. So I'm going to take off this breakpoint and wait for one entity to go through. And now if we go to results, we see that this entity, which was part type B, does the part type B tasks. It just happens to do both server 1 and server 2 tasks. So now we're getting a little bit closer where we are getting the right part type tasks done. Okay. So what we could do now is we could give the entity information and use, set a row so that it remembers what location it's at. So it could narrow it down even further, saying, the entity could get a row reference to server 1 or server 2, and that could filter down this table even further. But this is the time where we actually might want to use sequence routing. And the reason for this is that sequence routing gives us a way to point to a location and at that location say that we want to do XYZ things. So in this case, the sequence routing, we're going to make a sequence table and we're going to say we're going to follow, server 1, server 2, and then the sync. And we want to do that for each entity. So I'm going to put in a foreign key again, and I'm going to say that each entity is going to know its own sequence. So they could be individual sequences if we wanted. But in this case, it's going to be the same for each part type. Oops. And okay, so why do we do this even though it's the same information in all of these rows? Well, because we want to give it additional information that says, I'm going to be doing a specific operation for this part type at this location. So we need to have two different pieces of information kind of working hand in hand here. So I'm going to add a new column, and it's just going to be a string, and I'm just going to call this operation. I have a unique piece of information that is giving the relationship between the part type and the location. And here I'm just going to copy over something I have written out so we don't have to waste the time writing that out again. But so here it's just an operation name that says the part type and the location. And these are all unique, and I'm going to make this a key. So we actually don't need the server table anymore, and we're going to remove that row. And we're actually going to change this. We don't want to use this entity key anymore because it's not breaking it down to specific enough granular information that's helpful. For example, when we say part type A, we see all of the tasks for server 1 and server 2. So we need to distinguish that. And that's why we just made that operation string. So here I'm going to switch over to operation and I'm just going to input that really quickly. And part of the reason that we want to use a sequence table here, you don't have to use a sequence table, you don't have to use sequence routing. It's just helpful in this instance because the sequence routing is going to increment the data table information for us. Whereas if we weren't going to use the sequence routing, we'd have to make process logic that then decides, figures out which row to point to, and we'd have to add in some more logic for that manually. But the sequence table is going to take care of that for us. Okay, so getting that all filled in here. Now, can go back to the facility and we're going to change our routing. So I'm going to click on my output nodes and I'm going to say instead of continuing, we're going to route by sequence. And I want my entity to look at my sequence table. So now if I run and we go to results, we see that my server 1 for my B part type is doing only the tasks at server 1B, and my server 2, when I'm at server 2, my B part is only doing the tasks for server 2. And so I did that kind of quickly, so let's just actually take a step back. And I think it's sometimes helpful to look at the master detail view at a table. So I can expand this and I can see now when I have part type A and I'm at server 1, these are the tasks I do. If I'm at server 2 for part type B, these are the tasks I do. Okay, so a couple other things I wanted to go through. We're actually going to now talk about if you wanted to trigger a process in one of the tasks. So we're going to create a process and we're going to use a notify step as kind of a tool to understand our task references better while we're in a task. So here I actually want to just look at the processing, processing table. Oh my goodness. What is my table called? Table processing. Okay. So here I want to look at my table processing tasks table, and we're just going to look at the task name. So just keep in mind as you're using notify steps do need to use do need to have a string format. So if you're using numbers and you want to have your notify display a number, you'd have to convert it to a string. Here I'm using task name, which is already a string, so we should be good to go with that. Okay, so we're going to make this a warning, and we just want to put in a table reference into this notify. Since we still have our trace table resolution turned on, when we get to this notify, it's going to evaluate all of our table references we have at this point. So if I run, oops, I did not put that process in any location. Okay, so I actually want this on my last task of each of my last part tasks. So we're going to put finish task process 1 for A, B, and I believe that should be A, B, and C. Okay, so now if I run, as we get to server 2, we should get a notify step. So here again, our first entity that's going through is part type B. So if I pause, I can look and trace and I can see the row references that were available at that time. Okay, so talking a little bit further about row references and the difference between explicit, implicit, and potential. So here we can see there's different sections in trace. So we have our table references, we have our explicit selection, and then we have our potential rows. So we put this process in a task on our task sequence. Task sequences are driven by a token in the server executing the process for that task sequence. So our token has the specific row reference. So for example, again, we're part type B. So we see that we put this on the last task for part type B, and that means that that token, when we get to this task, or we get to this process, it sees that it knows row 12 in the processing task table. So why do we see this 3 here? Well, the explicit selection is actually that we are the third related row. So B has 3 tasks at server 2. So it's on the third related row, and that third related row is the 12th absolute row in this table. So sometimes you have to pay a little bit of attention as to whether you're looking at the related row or the absolute row. And you could see this similar piece of information here with the sequence table. So for the sequence table, part type B is we are at server 2 for part type B, so we're row 5. But for B, we are the relative second row. So let's say I wanted to actually do some rework. So we get through all of our tasks at server 1, and then we go to server 2. And for our last task at server 2, we want to check and see if we need to go back to an earlier part of our process or operation. So let's talk about rework and looping back. If you want to loop back at an existing task at that server, you'd really want to look into using loop back branches. And there's some good information and help on this, and there's also a symbit that shows this. So I'd recommend looking into those if that's what you are needing for your model. But if you want to go do rework at an earlier location in your model, that's sometimes more challenging because you have to deal with your row references and resetting those. So let's say at the end of server 2, I actually want to go back to server 1 and rework and do the tasks at server 1 again. How could I go about doing that? Well, we're actually going to use the process we just made, and we are going to say, so this process again is triggered on the last task of each of our tasks at server 2. Let's say first we want to decide if we need rework. So need rework. So maybe you don't want to rework everything. And in this case, for our verification, we're going to say currently we're going to rework everything just so we can test out this process. But this is just good practice, putting in steps that you might need later on. So first, do we need rework? Decide that. And then if we do need rework, we could transfer out of our current work at server 2. So we're going to use a transfer step. And we want to also make sure we release server 2. So we're going to release. And actually, it might be better to release server 2 before we do that. Okay, so for a release step, I'm actually just going to write server. I could specify server 2 if I wanted to, but as server 2 is the context object for this process, I could just write server, and it could then use whatever server is running this process as that information and fill it in and say, okay, I know server 2 is running this process, I'll just release server 2. So you don't always have to be super specific with what you're deciding to release as long as you have a reference to that object. And that way this process could be used in different locations, not just specific to that one location, or you don't have to make a process for each different location in your model. Okay, so we're going to release server 2, and then we're going to transfer from our current station. So we're currently in our processing station working on our tasks, and we want to transfer from our current station to the input at server 1. All right, so let's see what happens when we do that. And actually, let me put a breakpoint on our transfer step, and we're going to run. We get our notify. And now if we run again, we made it to our transfer step, and I'm going to step. And we saw our entity move from server 2 back to server 1. And actually, I'm going to, again, for verification to understand the behavior of my model, I'm going to change something so that I only have one entity in the system currently. So I'm going to say, my source, I only want you to make one entity. And that way, that's easier just for us to watch and understand what's happening. Okay. So we see that entity come back to server 1. We're at server 1, we're running, And then we get our notify step again. Well, what happened with that? Because that notify step should only be happening at our last task at server 2. So if I pause the simulation, we can go back to our Gantt chart and kind of use that to understand what's happening. So server 1, I did my server 1 tasks. Server 2, I did my server 2 tasks. I went back to server 1, and I'm still doing my server 2 tasks. So we're clearly not pointing to the right piece of information when we get to server 1. And that's because as we are going through our information, as we're going through our system, the entity as it's being routed is getting to a node that says route by sequence. It increments its row reference in the sequence table and then points to that row until it routes again. So as we leave the source, we are incrementing to this first row in our data table, or our first related row. In this case, if we're entity B, we're looking at this row, and we're pointing to this row until we route again. So when we leave server 1, we route again by sequence, so we increment our row again, and we're pointing to server 2. We go to server 2, we do this information. So if we're just transferring out of server 2, we're never incrementing this again, so we're still pointing to the same row, which is where we're having problems because we're looking then at server 2's task information. So when we get back to server 1, we still end up doing server 2's information. All right, so we need to reset our row references and change what row we're looking at. And as we talked about, there are a couple ways to set row references, but let's talk about changing row references. So there's two main ways to kind of change row references as you're running with process logic. So the first is the set row step, and that's really your most powerful way to set a new row, and the only way to set a new row. But you can also change row references by removing rows in case you were referencing other rows you didn't need to reference anymore. And you would do that with an unset row step. So this is a newer process logic step that we introduced in 242. And it's useful because you could either choose to remove all of the table row references for that token, object, element, etc. Or you could choose specific tables. So you could only choose to remove your row reference to one table or to a couple tables. So you have the power now to kind of be flexible and decide maybe you just don't want to look at this one table. You'd rather not have that key information anymore. So you could always choose to remove and unset rows that way. But in this case, we want to set a row, we want to reset a row, and we want to point to a different row in our sequence table. So we're going to use a set row step. So jumping back to our model, as we are transferring our entity back into server 1, we can just simply use a set row step before we transfer and say at our sequence table, we know we're going back to server 1, and our server 1 is our first row in, just so happens to be our first row for all of these situations. So we want to look back to our first row. Okay, so now if I run, we get our notify, we continue running, we get to our transfer step, and we continue to run. And we see that our entity didn't get stuck in a loop here at server 1. We correctly moved to server 2. And we can verify this again by going to results and looking at our Gantt chart. And we see that we did server 1, part type A and server 2, and then back at server 1, we did back to server 1. Awesome. Okay. Really quick, just to go over a couple other ideas. So say, for example, you didn't want to transfer the entity directly out of the processing station at server 2. Let's say you wanted the entity to move to the output buffer at server 2 and then move back to the input at server 1. And this could be maybe for a couple of reasons. Maybe you have other logic that's happening at the output at server 2. Maybe you need a transporter to move the entity. So instead of transferring directly to the input at server 1, let's say you want to move to the output at server 2. And how does that change our set row step? So as discussed earlier, when you go to route by sequence, you actually are first incrementing your row and then routing. So prior to looking at this first row, we actually start off at row 0. And then we get to a node that says route by sequence, and we increment to our first row and then route to this location. So if I need to say I want to go to server 1, and we're going to use the route by sequence, I actually want to set my row to the row before server 1. So in this case, I want to set my row to row 0. So for sequence tables, you can set your row to row 0, and that just means the row before the first row. So as we run step, and I just want to show and trace quickly, you could see that the set row step said we set the row for the entity before the first row in the sequence table. So you'll just see that in trace as before first. All right, and we saw that it moved to, oops, we'll see it again. It'll move to the output at server 2 and then return to server 1. And we can correctly verify that it's still doing the right tasks at the right location. Okay, and we're running out of time, so the last thing I really want to quickly show is what if you don't want to have all of the tasks done when you, or sorry, what if you want to go back to different operations instead of having each entity go back to the same server 1. So you could do that with your data table, and in your processing task table, you can add a new row or a new column. And again, we're just going to make this a string column, and we're going to say this is my rework operation. So instead of having all of the entities, the different part types go back to the same operation, we can give them we can give information that can determine which operation they go back to. So let's say I want C to go back to my C operation at S1. But I want my B operation to actually just restart over at S2. And we'll do A will also go back to S1. So here this is saying if I get to this task and I do need rework, I'd want to look at this piece of information to determine what operation I go back to. Okay, why did I make this a string? Well, you could see that it's the same piece of information that's determining the name of our operations. I could, you're seeing it's the same string as our foreign key. Why wouldn't I want to make this a foreign key? Well, then I would have two columns that point back to the same key, and that would be conflicting. So this would point to two different keys in the same table, and I can't point back to two different keys in a table. So we don't want to make this a foreign key, we want to make it a string. And making it a string is actually going to help us be able to correctly find the right row. So again, we're just going to use this piece of information to help point to the right row in our sequence table to then point back to the piece of information we need to be pointing to. So back in our process logic, instead of setting the row to a specific row number, we're going to use that piece of information. So again, we want to pick a row in our sequence table. We're going to say sequence table dot part operations, oops, or operation. And here we're going to use row for key. So row for key is a function that allows us to look at a key, which is a string, and it'll match that string in that key row. So here we want to find the operation name that matches in the sequence table that matches what we're putting in here. So we're actually going to put in the piece of information from the table processing tasks. So table processing task rework operation. So we're taking our rework operation string from our task and we're finding where that matches in our sequence table so we can set the row there. All right. So if we run, this is a part type entity A. So we should see the same behavior where it goes back to server 1. Step, oop, and we went back to server 2. Okay. So we went back to server 2 for the same reason we saw before, where we actually want to go one row before where we're routing. So we actually want to say -1. So we want to look at the row before, we'll increment to the row we need to look at, and then route. All right. So if we step, we now see we're going back to server 1, and we're doing that same loop again. All right, so that was part A, and that's kind of what we saw before, but I just want to check part B because part B should be doing something different. So if I select the source and I say, instead of making a random entity, I want to make row 2 because I know that's a part B, we can then do that. And we should see that part B goes right back to the input at server 2, which we do. And if we look at results, we can see that it's doing the correct information. All right, and the last thing I want to talk about is, so what if I don't want the task to do all of the tasks when I go back to do rework? So what if I go back to an earlier operation and I don't want to do all of the tasks for that operation? Well, you're feeding the whole subset of tasks into the repeat group. And you can't say that you only want to do part of these. You could do that at the task level by using a condition. So say you give the entity information that it's now doing rework. You could say, if this is a rework, do this task or not, but that would have to be at the task level. The other option you could do is you could make more operations. So you could make something that's like a rework. And as you go to do rework, this could be, a new set of tasks that you define here. So you'd have to make a new different subset of tasks or make your tasks conditional for your rework. You can't point to only a specific few tasks when you go back to do this. Okay, so that was a lot. Sorry, we did take quite a lot of time, but now I think if we have any time for questions, we can go over some questions.
Liz, no, a great job. I was going to try to interrupt you a few times to give you a chance to breathe, but you just kept rolling, so I just want to let you keep rolling. We do have some questions in the queue. I know we're probably only going to be able to get to maybe one or two of them, so let me just fire off a couple and we'll see how many we can get to, okay?
Okay.
Is there a way to see in process logic what the associated and context object is? Is there a difference in the two when trying to reference objects or properties?
Such a great question, and I did want to go over that, but again, we were rushing a little bit, so we didn't get to that. But yes, so as you're going through process logic, the notify step is again a really good tool to be able to look at the associated or context objects. So you can write in your message content, you could say look at the token, and then look at the token's associated or context object. And you do have to say look at the name because again, you want it to be a string. But that's one way you could use the notify step to get that information. And that will just help you better understand as you're running through a process or as things change in your process. If you have diverging branches, what is the associated or context object? And just in general, typically your associated object is the thing that is triggering the process. So as an entity goes into a server, the entity is triggering the process logic, but the server kind of owns that process logic, so it's the context in that case. So the entity is the associated and the server is the context. And sorry, I think there was a second point to that question. Could you say that again?
Yes. Yeah, there was. Hold on. Let me bring it back up because I was already moving on to the next question. The second part of it was, is there a difference in the two when trying to reference objects or properties?
Um, is there a difference? Um, Associated and context objects are going to be different pieces of information. So like I was saying before with this release step, I could just generally say server, and if the server is either the associated or the context object, it would use that information to then fill that in for the blank, kind of. But again, there's that hierarchy. So if, try to use the associated information before it would use the context. And if that doesn't answer the question, definitely email in and kind of, yeah, let us know if you have further questions on that.
Okay. All right. And we are right up against the wall right now. So we'll go ahead and leave the other questions in the queue. If anyone does have questions that didn't get answered, please feel free to reach out to Liz or I. I shared our emails at the beginning. I can share them again now real quickly. Let me just grab control back, Liz, okay?
Sounds good.
So without going to present mode or anything, there's our email addresses. So if you do have questions, feel free to reach out directly to one of us. Otherwise, thanks everyone for attending today. Liz, great job, and we will see everyone again in a month. Thanks again. Goodbye.